I mean,
I don't know. To be honest, I'm not particular.
So there's no certainty of definition.
No, words have multiple definitions, don't they? I mean, look up a dictionary. A word doesn't have a single definition.
Do you consider space as nothing?
Not really.
Why?
Because in relativity, space-time is like an object.
It's a physical space.
Yeah.
So that means it's something.
Yeah, I agree. Yeah. But the people,
So
I mean, I'm not suggesting the universe came from nothing. That's not my view. Okay, that's not my view. However, I do think the people that are suggesting it have been misrepresented because they're not claiming that the universe came from space. They're claiming that space-time itself can fluctuate into existence. That's what they're claiming. So when people say, "Oh, it's from space," which isn't nothing, but that's not what they're saying. So it's a mischaracterization of what they're saying, in my opinion. I mean, I'm not saying they're right. I don't take the view that the people that are suggesting
just don't agree
that.
With them. Yeah.
I think we don't know where the Big Bang came from. There are different ideas, and that's one of them. But it has, I think, been mischaracterized. So when they say universe from nothing, they mean from no space and no time.
So if you say something is not a physical, that means something it has to be, I mean nothing is not physical, that means nothing, it has to be something, let's say, metaphysical.
Well, what they're claiming is that it comes from the laws of physics, that they have their own sort of ontological existence in their own right. Yeah, that's what they're claiming. I mean, again, I'm not here to defend their view because I don't necessarily agree with it. Yeah. But let's at least understand what they're saying.
Yeah.
They're effectively saying the laws of physics have their own existence by themselves, if you like. And if you have the laws of physics, you can get a universe without any space and time that was there already.
But can you make things just with laws of physics?
I don't understand what you mean by make it with no physics.
If you know
what they're claiming is there would be laws.
Yeah.
If there's no laws, I don't think we would know what would happen.
But I know, but you need to make something.
Yeah.
You need the laws. Yeah, that's right. And also you need the material.
Well, I don't know that you do. I mean, what would happen if there were no laws?
Can you make something?
If we don't know. We don't know what would happen if there were no laws, right? We only live in a world with laws.
No, I'm saying.
So we can't say what would happen if there were no laws. We can't say one way or the other what would happen. We don't know.
I'm not saying without laws. I'm saying with laws.
Yeah.
If you have only laws,
yes.
Can you make something out?
Well, that's what they claim. Yeah.
Based on what? Like
they're basing it off quantum mechanics and applying it to. No, it's speculative. No, it's speculative. Again, sorry.
Isn't there something in the form of like energy?
Well, no. What they're claiming, and again, you know, you asked me what's the evidence. There isn't any. It's speculative. Okay, and I'm not claiming it's true. Yeah. I think the universe could easily be eternal into the past and never came from nothing because it was always there. That's another possibility. And I think personally, if I had to bet money, I'd bet money on that. Right? But we don't know. Okay. What the claim is in that in quantum mechanics, you can get particles that fluctuate into existence that weren't there before, and they randomly fluctuate into existence. That's not controversial. Okay, that happens. The controversial, yes,
something.
Yes.
So it's not nothing.
No, but it wasn't there before. It's spontaneously fluctuating.
Came about.
Okay.
But do we know?
No, hang on. Let me finish. Let me finish. Right. So what they claim is possible is that if you treat space-time quantum mechanically, then space-time can fluctuate into existence. That's what they're claiming. Now, I don't know if that claim is true, and there's no evidence to suggest that that's what happened. We don't know. Okay?
Yeah.
It's a speculative idea. Yeah. No one's claiming. I don't know anyone that's claiming this is what happened. Yeah. Right? Even Lawrence Krauss and Alex Valenkin, the people that like to talk about these ideas, I've never heard him say this is what happened. I've only heard them say this is one possibility for what happened. Okay, so as far as I can see, yeah, that maybe that's true. Who knows, right? But alternatively, it could be the universe has always been there. Yeah. So there's no.
I think if they were right, I would say that nothing for them is the law of physics, and the law of physics for us is something.
I would agree.
Yeah, it's something.
I would agree.
It's concept. It's not a physical thing.
I agree.
So that means that we conclude that nothing is a concept. In terms
Well, I
of
mean,
its
again,
existence. It's not something that physically exists.
Yeah, I agree.
Because if you say it is something that physically exists, that means it's something, obviously.
I mean, I agree. Yeah.
Yeah.
I mean,
philosophically, when you look at it like this way, that means if I say, I give you an example. If I say the sun as a star, if I look at the star as an object, if I know all the laws how to make star.
Do you have any questions?
Sorry, I had to interrupt.
No, I just suggested that.
Was it you? Was it?
No, he suggested like to Rob, like whether like you know.
On your level.
Sorry, go ahead. Sorry.
So I said, let's take example of the sun.
Yeah.
If we say the sun, the object, the star, the real object. If I know all the laws how to make the star, before it's there, let's say, imagine the sun is not there yet. So if I know only the laws how to make it, so I can say the star. For me, I can make it from nothing because I know already the laws how to make the sun. So if I knew all the laws how to make it, that means I can make it out of nothing, which is the law. If I know already the law in my mind.
Well, no, I don't necessarily agree with that.
That's why I suggest what they suggested.
No, I don't think that's correct. I mean, well, maybe. I mean,
that's not.
All right, here's my view of what their view is. I mean, again, I don't think we should hang ourselves up on this term "nothing" because it's just a word, right? I mean, who cares? I think that in these types of ideas, it's spontaneous. Quantum behavior is spontaneous. So you can't direct it necessarily. There might be some way that some advanced civilization could make a universe, but they would need some materials to do so. If you're talking about the sort of model, they're talking about the sort of models that they're talking about, it's by definition it's spontaneous.
Or maybe it's something, as you mentioned before, outside of the whole universe, which has like a different type of material that we know at all.
Well, you could say maybe to anything. Anything might be true.
The material we know nowadays, everything is changeable, right? So everything is there as not there at the same time. There's like a duality.
It's changeable.
It's changeable. If we came, like, let's say, sorry, if we one day discover kind of material which doesn't have this characteristic, then maybe you would suggest that came from that material.
Why?
Because that thing, you said that particular thing, I mean, the type of that particular thing is different than the type that everything in this universe is made of that particular changeable or duality particle.
But so you're hypothesizing something that doesn't change.
That maybe it came from that.
But why? You can say maybe to anything, right? There's nothing you couldn't say maybe.
Yeah, because this is also
the question is, what do we have evidence
for? Why everything is changeable, having this duality? There's no such a thing that is constant, that there is no change or no death? Because for living thing there's death, but for not living thing there's change, as far as I know. So death for not living is
right. But I don't see what you're getting at.
I mean, I'm saying like. This is what my question, like, why everything? There is no such a thing that is constant, it doesn't change. That is infinite, as you said.
Well, I mean,
because infinite, it should be, doesn't change, it should be...
Infinite doesn't change?
Yeah.
Well, I'm not... Did you find it?
No, he just said that at the moment it doesn't have... There's one guy that was a Christian preacher, became Muslim now again, so that everybody's over there now. So.
Okay. I mean, well, if you take something that's infinite, okay, it can still change. Yeah.
And it's infinite.
Yeah.
Because you said it's changing. That means it has a beginning.
Sorry, that it
has a beginning.
Why? It doesn't mean it has a beginning. No.
It can be changeable and
it could be eternal.
Eternal.
Might be.
If it is eternal, because you contradict it, if something is eternal, it has to be the same thing eternal all the time.
Why?
Because you said it's eternal. So it has
that doesn't mean it can't change.
No, if you change, it becomes something else.
No, it's still eternal, isn't it? If the universe has no beginning or no end, it's eternal. Agreed?
If the universe.
Yeah, if. I'm not saying it does. I'm saying if it does.
Yeah.
Okay? So if that's the case, does that mean the universe can't change? Of course the universe can change.
No. Why?
Well, why can't it? Tell me why it can't.
Because it's no longer universe. Because it's something else. You said it's something else.
No, but if it changes, okay, let's suppose the universe is going to expand forever and ever and ever into the future. Okay?
Yeah.
There'll still be fluctuations in the temperature of the universe. Agreed?
Yeah.
So it's changing, and it's expanding, so it's changing, but it has no end, so it's eternal, or it may have no beginning.
No, but when you said expanding, that means what we understand from expanding is like it started from a point.
No, it doesn't mean that at all.
How can it be expanding and it's eternal expanding and without a beginning as well?
Why not?
How?
Okay, let's say it bounced. Let's suppose it was collapsing and then it bounced back out. That would be, we would see an expanding universe and we would see eternity to our past. What's the problem with that?
What was the first?
It may have no first.
No, you said,
there is
let's say at the first it was...
No, I never said that.
No, what did you say?
I said you can have an eternal universe that's changing in time, right? It's still undergoing change, right?
So, but when you
if it collapses down, expands back out, the universe is undergoing change.
So for you, in that, in this theory, that you mean that even the time is eternal, so there's no beginning for time as well.
In that case, there would be no beginning of time, yeah.
How is that possible?
Why wouldn't it be possible?
Because every moment is dependent on the moment before it. So...
I think you're thinking...
You come...
Okay, so what?
So it has to be... Otherwise, I won't come to that...
No, okay, that's not... I don't agree where you're thinking here. You're thinking that the universe is on some kind of journey from the endless past to today. The universe is not on such a journey, yeah? The universe exists. Yeah, it's not moving. You might be moving through time. You change, but the universe itself is not moving through time. The universe exists. Yeah, things in the universe can change. In that sense, that's the sense of what I mean by things are changing. Okay, but there's no. You don't have to have something. The universe itself exists. Right?
Yeah.
It doesn't...
There's no doubt about that. I know. But the problem is the time what we know, that every minute is dependent on the minute before it. So how do you know the time that applies for the universe? Like how do you know that this universe...
Well, we don't. I've never claimed we know, right? I've never claimed we know. I'm saying these are possibilities. So there's no statement here, I know the universe is eternal, or I know it came from a quantum fluctuation. There's no statement of knowledge there. I'm saying these are possibilities. And there's no logical contradiction with saying the universe is eternal into the past. Okay? One of the things that maybe you may not be familiar with is, I asked Roger Penrose, who's one of the founders of this branch of physics, you know, about, well, not the founder, I mean, he's one of the leading figures, shall we say, in this field. And he thinks the universe is eternal into the past, and I asked him, well, ask him your question, how did things get to today? And the thing is, the only thing that's going to get to today is what? It's not going to be massive particles. It's not going to be particles that have mass. It'll be energy or space-time or something like that. Now these things don't experience the passage of time. Yeah? Or at least not the sort of time that we experience. They experience all moments of time at once, because are you familiar in relativity that when you travel at the speed of light, your clock stops? So you experience all moments of time at once. Are you familiar with that? Okay, so if you take that and think, okay, if the universe is eternal into the past, what is it that is eternal? Again, it's not going to be particles that have mass. It's going to be things that don't have mass, and they can experience all moments of time at once. So there's no contradiction with it being eternal.
It's like we just came about. Like,
I'm not saying we just came about.
Yeah, like while the universe is already exists, eternal, and we just like part of his changeable.
Yes, we're the changeable elements, if you like. The universe itself, you know, exists. Yeah, but we are the bits that change. So things that are true for us are not necessarily true for the universe as a whole. Yeah, obviously, because obviously we're surrounded by space. Obviously the universe isn't surrounded by space because the universe is space. So they're obviously true that there are things that are true for us that aren't true for the universe. I mean, to me that seems obviously true.
That we cannot maybe understand, that means that it's true. The thing that we cannot understand and we cannot explain,
okay, I mean,
those are the things that...
To me that seems
true.
like a good guess. How about that?
Why?
That there are things that are true of things in the universe and not true of the universe. That seems like a reasonable guess, shall we say. Okay, I can't claim it definitively.
Yeah, it's still just as you said, theory or guess. But there's no scientific explanation for it.
Explanation for what?
For your theory or for your...
Well, there are, it depends what you mean by a scientific explanation. There are theories that I think have good consistency that imply this is the case. We don't know them to be true, so it's true. So what we can say about the origins of the universe is we don't know. Right? We can trace the evolution of the universe back to about 13.8 billion years, and before that, currently, we don't know what happened.
What's that based on? Like, you know, that measurement?
Sorry?
That measurement of 13.4 million years.
13.8 now.
0.8.
Yeah.
I mean, what's that based upon? Like, you know,
how is it? Okay, yeah. So there are different ways to do it. One way is to look at the Hubble Space Telescope. Their key mission was to look at distant supernovas and work out the expansion of the universe from measuring the distance to those supernovas. So just to give you an example of how you can measure distance in space, I'll give you the simple. So yeah, but redshift itself is not giving you distance. So the simplest way to give you distance, which won't work for large scales, is to use something called parallax. So parallax is if you hold your finger up, shut one eye and shut the other one. Go on.
Yeah.
You see that your finger moves position.
Yeah.
Now move it out here and do the same. You see it moves slightly less.
Yeah.
It moves less.
Yeah.
So you can do stellar parallax, so where you take the Earth in the winter and Earth in the summer, and you look at the position of stars and you see how they shift. That'll give you distance to stars. Okay. And then there's other techniques that give you more and more distance. So the best one for long distance is what's called type 1A supernovas. What they do is they have a known light curve when they explode because the physics of how they explode is very well known. So therefore, if you know how bright something is and you know how bright it appears, you can work out how far away it is. Because if you see like a light, you can see it's got a certain brightness, but you don't know, is it really bright far away or is it not so bright but close?
Gotcha, yeah.
Right?
I remember Jim and Khalili done a documentary like that. Yeah.
So with type 1A supernovas, they think they understand the physics pretty well. So you can work out distance and you can plot that over time and then you can map out the expansion of the universe. The other way you corroborate it is look at the cosmic microwave background. That's the oldest light that we can see. Okay, so there are measurements you can make of that will also tell you how we get to that, and then you compare them. And they roughly agree. They don't. I have to be honest. They don't actually precisely agree. So they're actually slightly out with each other, but they're only out by a little bit. So most people aren't really worried about that. It's like, you know, probably we need to refine our measurements a little bit. So they are not quite perfectly consistent, but they are very close to each other. It's not like one saying 13.8 billion years and the other one saying 100 trillion. You know, they're pretty close. So you take these different methods and you...
But mainly based on the expansion of the universe, basically.
Yeah, you're winding it back. You're looking at distant stars, you're looking at cosmic microwave background, and they can give you information. So when we say the universe is 13.8 billion years old, what we mean is that's the amount of time that's happened since we can infer back. It doesn't mean there was nothing before 13.8 billion years old.
Is that from the Big Bang point?
Well, it depends how you define the term Big Bang, because Big Bang has different definitions. So this is the problem. Words don't have single, or phrases don't have one definition. There's two ways you might define Big Bang. One is it's an expansion from a hot, dense state. Okay, so we know the universe was in a hot, dense state and it expanded. Okay. Another is to say it's an expansion from what's called a singularity, which is where the universe is infinitely dense, infinitely curved, infinitely hot. That is a theoretical extrapolation, and Penrose and Hawking showed in the 1960s and 70s, based on earlier work by Friedman and Lemaitre, that making certain simple assumptions, the Big Bang must have had a singularity, and that means time stopped at the Big Bang, and there was no before the Big Bang. It doesn't make sense to talk about before the Big Bang because the space-time got infinitely curved, so you can't continue the evolution before that. However, those singularity theorems have assumptions which people now don't think are likely to be true, including Penrose and Hawking themselves. And so, therefore, the question is open, well, what happened then at the Big Bang and maybe before? Now we can ask what happened before the Big Bang. But in order to answer the question, what we ideally would like, what most cosmologists would say, we need a theory of gravity that includes, we've got Einstein's theory of gravity, it works very well in most cases, but it doesn't include the effects of quantum mechanics, which is the science that you need to understand subatomic particles. Why would you want that? Well, because if the whole observable universe is smaller than a subatomic particle, then you need to include the quantum effects. And right now we don't know how to do that. There are a number of proposals to how to do it, but they haven't been experimentally verified, so we don't know if they're correct. What they have, they do seem to converge on this answer that the universe bounced. That's the common view. It's not universally held, but it's a common view.
You know it's Sunday.
So that's a very strong possibility, in my opinion. Another way to define Big Bang, we could just say it's the moment that the inflationary era ended, because cosmologists think there was a period of very rapid growth called inflation. When that ends, it heats the universe up. So you could define the Big Bang as the moment that inflation ended, in which case we can say easily what happened before the Big Bang. There was inflation, which is a very rapid expansion of the early universe. Of course, you could still ask the question, well, what happened before inflation? And then then you come into these quantum gravity theories. So we don't know, but anyone that says they do know, treat them with caution. But that doesn't mean there aren't plausible ideas on the table. And certainly some of them will say the universe is eternal, and some of them will say it could spontaneously form. Or there are other possibilities. One is that time is what's called emergent property. So you could have a state where there's something existing but not time, and then time starts ticking. So that's another possibility, what we call emergent time. So there are a lot of ideas that are on the table, but at the moment we don't know which one is correct.
When you said about the universe is eternal, and it's let's say only us here, which is not eternal basically, and we are changeable. But when I mentioned to you, like every particle in the universe is changeable. So if the universe, because when you use a logic deduction here, if the universe, all of it, made of particles, and then you got all particles are changeable.
Well, but I think contemporary physics doesn't say everything is made out of particles. I think better to say what we think is fundamental are probably fields, and particles are what you get when you excite a field.
Yeah, including the field. The field is something, it's not nothing. Yes.
Again, I'm not saying it isn't.
It's a space. Physical space, which is something. And it's changeable?
Yes, it's changeable.
Yeah, because when you say the universe is eternal based on...
I didn't say it is eternal, I said it might be.
It might be. No, that's what I'm saying. That's why I'm saying, I don't take this as even as a theory, because I find a problem with it, which is if everything made in the universe, made of, as you said, field and particles or molecules, everything is changeable, I find it difficult to accept that the universe, it doesn't have a beginning and it's eternal.
Why? I don't see what changeable and not having a beginning are related.
Yeah, because if you have something is a changeable, that means have a beginning, you have an end.
Why?
Beginning,
it doesn't mean that.
If it is changeable, that means...
Why does it mean that? I know you keep saying if it's changeable it means it has a beginning, but you haven't given us a reason why. Why is that statement?
Because it's changeable.
Okay, now that's just a restatement of what you've just said. It's not an explanation. Can you explain to me why that if something is changeable, it can't be eternal?
I give you.
I don't understand.
I tell you why. Example. Let's say example. I know maybe it'll be a stupid example, but let's hypothetically these glasses will turn into a bottle of water. So if it is something, and then it's changed to a bottle of water, it's no longer glasses, it's a bottle of water.
Yes,
it's something
changing,
else. Yeah, so this thing, it has a beginning, and it has an end.
Right,
before it became...
but when it was the glasses, it was made out of atoms, agreed?
Yeah.
Okay. And when if you could somehow turn that into this, right? They're still made. The atoms are always atoms are there in both cases. Agreed?
Yeah.
Right. So there's no reason why the atoms couldn't always be there. Although actually in this case we're not talking about atoms always being there, but I'm just trying to use your analogy.
Yeah.
Yes, the sunglasses, when they became the sunglasses, they had a beginning. Yeah. But when we say the sunglasses began to exist, what we mean is they were made out of prior materials. Yeah? Everything is made out of some material. Yeah. Okay? Or everything like...
This is a particle. This is a particle.
Yeah,
We go down until let's say this is a particle. We talk about particles or two particles that made something. Yeah. These two particles, after we apply.
Well, let's just take an electron, let's say. Yeah, go on.
You mean the electron?
So why couldn't that always exist?
The electron is always...
Well, the electron has mass, so let's get something that doesn't have mass. Let's take a photon, right? Photon doesn't have any mass. Why can't that have always been there?
The photon is always there. So this is maybe the only thing that we can say is something is eternal. Photon. Can the photon be eternal?
I'm just trying to ask you why it couldn't be, because you're saying there's some logical problem with that, and I don't see what the logical problem is. All you keep saying is if something changes, then it can't have a beginning, and I'm asking you why, and I don't see any reason why.
Isn't this about teleology?
You can give it whatever label you like. I'm not sure how that adds to our conversation.
So you mean like it's like a circle? So
no, it could be like a circle, but I'm not saying that it is like a circle.
No, I mean your
a circle is a cyclic thing.
Yeah,
and the universe might be cyclic, I don't know, but I'm saying it doesn't have to be cyclic. I mean, if you take a bouncing universe, for example, you have a period expanding out forever, and on the other side contracting back forever. That's not cyclic, it's not like a circle. It's perfectly logically consistent, and it's implied by many theories of quantum gravity. So it seems like the most reasonable assumption to make. I mean, again, we need experiments to know what really happened, so we don't know what happened, but there's no logical problem with that. I don't see what your logical problem with that is.
The logical problem, what I said, is because everything is changeable, including particles, everything that made the universe is changeable. That means the universe is changeable as well. That means the universe was in a state.
But, okay, let's suppose yes.
And it changed to another.
I mean, first of all, I'm not sure what you mean by universe being changeable, because you could describe this state as like a block. Well, things in the universe would change, but the universe you could just consider it as just sort of sitting there, like a sculpture, if you like.
So you're talking about universe excluding us, excluding the creator?
No, not excluding us. We're part of the universe.
So,
but again, why? Let's just get back to the point. Why is it? I mean, we're going around in circles here. I'm not sure we're really getting anywhere. I don't understand why, if something changes, it must have a beginning. I just don't see that.
If you use the logical deduction,
I don't see what the logical deduction is.
Yeah, that's what I said.
You can use the word logical deduction.
No,
but you have to give us some logic.
Okay, so the logic is the universe is made of particles. All particles are changeable. That means the universe is changeable.
Okay, we're just going around in circles. I don't see where we're not getting anywhere with this.
Because you can't take out...
What's your name, sorry?
Ishmael.
Ishmael, we're just going around in circles here, aren't we? I don't see... This conversation is not going anywhere.
Why